Okay, in this video, we're actually going to calculate the derivative or slope of the following parabola. So the original function is f of x equals x squared minus 4x plus 7. And we saw in our last video that the formula to calculate the slope when you have a curve, which is called the derivative, is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. So let's actually do the calculation. So, and this may be, this might take me 2 videos to do, but I'm gonna literally just follow the formula. So f prime of x equals the limit as h goes to 0 of f of x plus h. Okay, so let's think about what this means. Let me just do a side example here. If I had, I don't know, f of x equals like, I don't know, x plus 3, and I told you to calculate f of 1, right? You would know that 1 is an input and 1 would have to go in for x, so you would go, oh, let me just substitute 1 in for x, and I would say 1 plus 3, and you'd say that f of 1 equals 4. So when the input to the function is 1, the output is 4. Similarly, if you had, I don't know, I'll make this up, f of smiley face, right? I know that sounds ridiculous, but you would know, oh, I need to plug the smiley face in for x, and I'd have smiley face plus 3. So if you had f of x plus h, right, you'd go, oh, well, that just means I have to plug x plus h in for x, right? So you'd go like that. And all you're doing is essentially substituting, okay? So the idea then is to take x plus h and put it in anywhere you see an x, okay? So how do we substitute? You guys remember this, I hope. We substitute using parentheses. So I'm gonna do parentheses squared, right? Minus 4 times parentheses plus 7, and anywhere I see an x, I'm literally substituting in x plus h. So here goes, x plus h, x plus h. Okay, so I'm following the formula. That's this part of the formula. Then the formula says, and I'm gonna have to scroll over a little so you can see. So I'm just gonna do this a little bit. Minus f of x. Well, f of x is this whole thing here. So minus, and I'm gonna put this in brackets because I have to subtract the entire function, x squared minus 4x plus 7. Okay, so I'm literally following, and I'm going to move this over, the formula, okay, and I'm substituting everything into the formula divided by h. Okay, so we're going to keep this limit as h approaches 0. The last thing we're going to do is let h approach 0. So we're now just going to do the math. So limit as h approaches 0. And let's do the math, right? The quantity x plus h squared, if I, distribute, that's going to be x squared plus 2xh plus h squared. Now I'm going to distribute here. This is minus 4x minus 4h plus 7, and I'm probably going to run out of room. I should have written a little smaller. Minus x squared plus 4x minus 7 over h. Okay. Now, I'm going to clean this up a little bit. I'm going to, just sort of combine like terms, cross things out. And we're going to notice a lot of things cancel. X squared and negative x squared cancels, negative 4x, positive 4x, 7, negative 7. And essentially, we're left with the limit as h approaches 0. So I am writing that on the left. And I'm left with 2xh plus h squared minus 4h all over h. Okay, now, you know that if you see a fraction, and just so you guys know, I have the limit as h approaches 0 on the left. If you see a fraction, you have to reduce it. So this is an Algebra 2 skill that you need to know. And if you notice the top, you can factor out an h from the numerator. So I'm going to do that. I'm going to make this h over 2x, right? I'm taking out an h plus h minus 4. So make sure I did that correctly, all over h, and the h's are going to cancel. Pretty cool. Okay, so now I'm going to actually have to erase and draw the rest at the top. So hopefully you have this copied, or you can pause the video. So let me do that. And in that next step, I'm going to have, I'm going to just write it out. So f prime of x equals the limit as h goes to 0. You got to keep this in until the very end. And we said we're left with, when the h's cancel, 2x plus h minus 4. Okay, now, at this very last step, this is when we let h go to 0, or h approach 0. It's not going to ever technically equal 0, but it's going to become so close to 0 that you're not going to know the difference, right? So think about what happens in this expression if h approaches 0. H basically, for all practical reasons, you can't see it, it's so small, right? So that tells me that the derivative, or the slope or rate of change, now I can drop this, is equal to 2x minus 4. So this is interesting, right? The derivative is actually a function of x. Think of the derivative like a dependent variable. Okay, the derivative, or the slope of the function, literally depends on where you are for x. X is like my independent variable, right? So what this means is I can find the derivative or rate of change for any x value by substituting in. So if I want to find the derivative when x equals 3, right? So I want to find the derivative when x equals 3. All I need to do is plug that into the basically formula for derivative. I just found that formula for this particular function. So I could say f prime of 3 equals 2 times 3 minus 4. And I can say that the derivative, or slope, or rate of change when x equals 3 on this particular parabola is going to give me 2. So if I were to draw this out, and I were to graph the original function on Desmos, and I look at the point x equals 3, the slope at that exact point would be a slope of 2.